Hi guys, so we're ready to look at section 9.6, division of radicals and rationalization. So the very first concept is just kind of a reminder of the simplified form of a radical. So it's just a recall. So recall that if a radical expression is simplified, that it has to meet three conditions, and it's these three conditions here, right? We need, and just a reminder, like if I have, I don't know, the cubed root of x squared, right? Remember that x squared, that is called my radicand, right? It's the part underneath the radical, and this number here, remember, is called the index. Right, so just a quick refresher of those terms, and then that symbol, that like square root symbol, that's called a radical, right? So remember, we need the radicand to have no factor raised to a power greater than or equal to the index, right? So in other words, in this example, we can't have anything raised to a power greater than or equal to 3, right? Also, the radicand does not contain a fraction, and no radicals could be in the denominator. Right, so concept 2 is looking at the division property of radicals. So this is somewhat similar to the multiplication property of radicals, and it really relies on exponent rules. So let me write that out. Right, so if we let A and B represent real numbers, such that the nth root of A and the nth root of B are both real. Then the following is true. So if I have the nth root of A over B, that's equivalent to the nth root of A divided by the nth root of B, right? Where B cannot be equal to 0, right? Because we can't divide by 0, right? And I'll actually come off to the side and just show you a couple of things, right? So if I have the nth root of A divided by B, right, I can show that this is equal to what I had just written, because I could first show this using the idea of a rational exponent. So this would be the same thing as A over B raised to the 1 divided by n power, right? Because remember, we used to do 1 divided by the index of the whole radicand, right? And then we have an exponent rule. So if I have, let's say, x over y all raised to the, I don't know, mth power, right? This would be equal to x to the m divided by y to the m, right? This is an exponent rule of a quotient. So I can apply that here. So this would give me a to the 1 divided by n divided by b raised to the power of 1 divided by n, right? And then I can rewrite this now using the rational exponent as, using it with a root symbol. This would be the nth root of A divided by the nth root of B, right? And then we got to the point where we want, right? So this is all, using the idea of exponents. And then just a few quick examples. So if I have like the square root of 25 over 36, right, the square of the whole thing, this would be equal to the square root of 25 over the square root of 36, right, which equals, so radical 25 is 5 and radical 36 is 6, right, so that equals 5/6, right? So it can be helpful sometimes in order for us to simplify radicals, right, of a fraction. Another example is that we can work the other way, right? So if I have the cubed root of 125 divided by the cubed root of 8, right, then this is just equal to the cubed root of 125 over 8, right? The important part, though, that I want to point out is that these indexes must be the same, right? And just like, this index, these are 2's, just like when you split them apart, those indexes are the same, right? So that's important to note, right? So let's look at some examples. Right, so example 1, we're asked to simplify the expressions. So the very first one, we have the square root of the quotient of x to the 4th and y to the 10th. Right, so this would be equal to the square root of x to the 4th divided by the square root of y to the 10th. Right? So then I can think of x squared, or x to the 4th, as x squared squared, right? Because remember, we multiply powers when we have a power raised to a power, we multiply those, right? So then this would be divided by the square root of y to the 5th quantity squared. Right, and the reason why that's useful is because if I can write an expression that's squared that matches this index, right, because the index out here is 2, then those will just cancel out, right? So this becomes just x squared divided by y to the 5th, right? So same thing here. We have the cubed root as my index now. So I would think of w raised to the 7th power as w to the 6th power times w, right? Because w to the 6th times w is equal to w to the 7th. And the reason why I'm kind of pulling out that 6 is because it's the biggest multiple of 3 that's less than 7, right? And then the 64, I can break down into prime factorization. So 8 times 8 is 64, right? And then 8 is 2 times 4, and 4 is 2 times 2. So we get those 2's, and then here we get 2 times 4, and then 2 times 2. So we actually get a collection of, 6 2's. So 64 is 2 to the 6th power. Right, so this would be 2 to the 6th power. So then this is equal to, so this would be the cubed root of w to the 6th times w all over the cubed root of 2 to the 6th power. So that's just using that quotient division property of radicals that we just talked about. And then I can use the multiplication property of radicals, right, to split up the top. So that would be the cubed root of w to the 6th times the cubed root of w all over the cubed root of 2 to the 6th power. Oops. And then I could rewrite w to the 6th as w cubed. Wait, no, we would want to do w squared cubed times the cubed root of w all over the cubed root of 2 squared quantity cubed, right? So we're trying to break up that 6 exponent. So then this would be equal to, so the cubed root of w squared cubed, right? In other words, this cubed root and this third exponent, those cancel out, right? So we're left with w squared, and then there's nothing I can do with this guy, right? So I just write that down. And then same thing here, this and this cancel each other out, so I'm left with 2 squared, right? And then I can clean this up because I can simplify the 2 squared, so this would be w squared times the cubic root of w, all divided by 4. Right. So that's my final answer for part B. Right, so then example 2, I'll try to simplify this expression. So in this one, it might be helpful to kind of do the reverse of the division property. So in other words, I can make this be the cubic root of 16y to the 4th all divided by y, right? And the reason why that's helpful is because, if I have, x to the n divided by x to the m, remember the exponent rule, we subtract their exponents, right, when we divide with the same base. So what this is going to become is the cubed root of 16y y to the 4th minus 1, right? Because it's understood that has an exponent of 1 in the bottom, which gives me the cubic root of 16y to the y cubed, right? So that's helpful to me because I'm taking the cubed root. So if I can get y to the cubed, like to the 3rd power, that's awesome, right? So then this would be equal to, and I might come off to the side and worry about 16, right? So 16 is 4 times 4, and each of these is 2 times 2. So the prime factorization of 16 is 2 to the 4th power, right? So we're going to rewrite 16 with 2 to the 4th. So this would be equal to the cubed root of 2 to the 4th times y cubed. Whoops, sorry about that. Right? So then this would be the same thing as the cubed root of 2 to the 4th times the cubed root of y cubed. So using that multiplication property of radicals. So then I want this, this is not simplified, this 2 to the 4th, the cubic root of 2 to the 4th, because this 4 is not supposed to be bigger than the index, right? So we need to try to pull out some, make it less than that, right? So what we could do is the cubic root of 2 cubed times 2 would be 2 to the 4th, right? And then times the cubic root of y cubed still. And then this would be, so using that multiplication property again, this would be the cubic root of 2 cubed times the cubic root of 2 times the cubic root of y cubed. So then the cubed root of 2 cubed is just 2. Same thing here, right? The cubed root of y cubed is just y. And then we'd have the cubed root of 2 left over, right? That's here. So that's that would be simplified, right? 2 times y times the cubed root of 2. So then concept 3 and 4, we're going to look at what's called rationalizing the denominator, right? So remember, if we go back up here, number 3, that no radicals are in, no radicals can be in the denominator of a fraction in order for it to be simplified, right? So rationalize the denominator is going to be a way for us that we can remove this. So I have here the process to remove a radical from the denominator is called rationalizing the denominator, right? And in concept 3, we're going to focus on having just one term in the denominator. Right, so something that we want to just recall a little bit is if I have the square root of x squared, this is just equal to x, right? And of course, x has to be greater than or equal to 0 here, because underneath an even index, right, the radicand has to be bigger than or equal to 0, right? So then if I had the cubed root of x cubed, that's just equal to x, right? If I have the 4th root of x to the 4th, that's just equal to x. And of course, that's assuming x is bigger than or equal to 0. If I have the 5th root of x to the 4th, this is going to equal to x, right? We could keep going, right? Whoops, sorry, that should be x to the 5th. It's getting a little, right? So the 5th root of x to the 5th is just equal to x, right? We could just keep that process going. So the idea with that is if I can get a power that matches the index, then that will remove the square root symbol, which is what we want to do, right? We want to remove the radical from the denominator. So I have just a note here. So we need to use the multiplication property of radicals to create an nth root of an nth power. Right, so we want to try to create this scenario, right? Another thing that I want to remind you off to the side is just like if I have a fraction like 1/5, it's okay for me to multiply it by like 3 over 3, right? Because this 3 divided by 3 is just equivalent to 1. So, this would just become 3 over 15, 3/15, right? So I just want to remind you that if I take a fraction, I can multiply it by the same number over the same number and get an equivalent fraction, right? We're essentially just cutting it in more parts, right? So we're going to use that idea and this idea with radicals in order to get rid of that. So in example 3, it says fill in the missing radicand to rationalize the radical expression, right? So in other words, what do I need to put in the question mark in order to get rid of the radical sign, right? So in other words, in this case, what I'm thinking in my mind is I want to get this situation, right? So this is my thought, right, or my goal. So I want this has an index of 2, so I want every factor to have the same, have a matching exponent inside. So here I just need, the question mark, is this going to be equal to 7, right? Because if that's 7, that would have the square root of 7 times the square root of 7, which equals the square root of 7 times 7, which is equal to the square root of 7 squared, right? So that's what gets me that goal that I want, right? So in part B, notice the index is 5, right? So I have a t squared in here and then a question mark. So what my goal is I want to get the 5th root of t to the 5th power, right? So what would I have to multiply by t squared to get t to the 5th, right? I would need t cubed, right? So the question mark is equal to t cubed, right? Because if I have the 5th root of t squared times the 5th root of t cubed, that will give me the 5th root of t to the 5th, right? Because t squared times t cubed is t to the 5th, and that, of course, just gets me to t, right? So we get rid of the radical, right? And then lastly, part C, I have the cubic root of 5x squared times the cubic root of what? We'll get rid of the radical, right? So everything inside I want to have be cubed. So in other words, my goal is to get the cubed root of 5 cubed times x cubed, right? So in order to get 5 cubed, I would need to multiply by 5 squared. And then, I have an x squared already, so to get that to be x cubed, I need another x, right? So then this would just be 25x, right? So that's what the question mark would be for that last one. Right. So example 4, we want to simplify the expression, and we can assume that y is positive, right? It's greater than 0. So 2 divided by the 4th root of y, we want to simplify, right? So the problem here is that we have a radical in the denominator, right? So what I can multiply by is the 4th root of y cubed, right? Because what I'm thinking about is I want the 4th root of y to the 4th is kind of my goal, so that way those things cancel and I get just y. So this is y to the 1st, right? So I need to multiply by y cubed in order to get that to be y to the 4th. And then remember, like when we split up fractions, we have to multiply, we multiply the top and bottom by the same value because we want this just to be equivalent to 1, right? So I'm taking my original expression and multiplying by 1 and just changing how it looks. So then what this becomes is 2 times the 4th root of y cubed all over the 4th root of y times the 4th root of y cubed, right? So then using the multiplication property, this would be the 4th root of y times y cubed, which is y to the 4th, and then the top would just be 2 times the 4th root of y cubed. So the 4th root of y cubed is simply just y, and the top would be 2 times the 4th root of y cubed. Right? So that's simplified. So in example 5, we have to simplify the expression the square root of 8/3, right? So the square root of 8/3 is equal to the square root of 8 all over the square root of 3, right? So I need to rationalize the denominator, so I would multiply by radical 3 over radical 3, which gets me to the square root of 8 times radical 3 all over the square root of 3 times the square root of 3. So we can use the multiplication property. So this would be the square root of 8 times 3, right? And this would be the square root of 3 times 3. So then this would be the square root of 24 divided by the square root of 3 squared. So this would be equal to the square root of 24 over just 3, right? Because that'll cancel out. And then we can simplify this. So the prime factorization of 24, we know we have 8 times 3, and 8 is 2 times 4, which is 2 times 2. Right, so the prime factorization of 24 is 2 cubed times 3. So if I fill that in, right, so what I'm thinking is I can't have that factor raised to an exponent bigger than 2 because that's my index. So I need to somehow reduce that cubed power, right? So what I can do is rewrite 2 cubed as 2 squared times 2 times 6. And we want the square root of that all divided by 3. And then I can rewrite this as the square root of 2 squared times the square root of 2 times 6 all divided by 3, which equals, so the square root of 2 squared is just 2. And then I can't do anything with the square root of 2 times 6 except for just multiply 2 times 6, which is radical, or wait, we can break that down more. Hang on. I got a little ahead of myself. I was thinking 2 times 3 is 6, and I wrote 6. So that should be a 3 there, and this should actually be a 3 as well, right? Because what I did is took 2 cubed and just rewrote that as 2 squared times 2, right? That's 2 cubed. Sorry about that. So that would be, so here would be, so 2 times 3 is 6, right? And then divided by 3. And that's as simplified as we can get, right? 2 times square root of 6, all divided by 3. So then example 6, we have 18 divided by the cubed root of 3y squared. So I don't want a radical in the denominator. Right, so to figure out what I need to multiply by, I'm going to want 3 cubed y cubed, right? So I have 3 to the first power, so I need to multiply by 2 more. And then I have y squared already, so I need 1 more y. Right, so in other words, I'm multiplying by the cubed root of 9y. Right, but I'll just leave it as 3 squared for now. So this becomes 18 times the cubic root of 3 squared times y, all divided by the cubed root of, and then you multiply these together, right? So that gives me 3 cubed y cubed. So then this becomes 18 times the cubic root of 3 squared y, all divided by, and these 3's will all cancel out, right? We're left with just 3y, right, in the denominator, because I have the cubed root of some things cubed. So then this would be equal to 18. Well, I can divide the 18 and 3, right? So that would leave me with 6 on top, right? 18 divided by 3 is 6. All right, so this would be 6 cubed root of 9y, all divided by y. All right, so just cleaning that up a little bit, reducing. So 3 squared is 9, and then 8, like I said, 18 divided by 3 is 6. Right, so the next concept is the same idea, but what happens when we have two terms, right? So we need to recall something really quick that we'll need. So if we have a difference of squares like a plus b times a minus b, remember this equals a squared minus b squared, right? And we looked at before about multiplying polynomials, but also with factoring, right? If how to recognize this part and that it factored in this fashion, right? So the nice thing about this is notice that no matter what a and b are, if they're square roots, then I'm going to be squaring them, right? So since a is squared and b is squared, this helps us kind of get rid of square roots at least, right? So in other words, this idea will ensure that we don't have a square root in the denominator, right? And this is basically thinking that a or b could be a radicand of a square root, right? Now if it's a different index, that won't necessarily hold true, and you have to do things a little bit differently, but with square roots, this can be helpful, right? And just another note here is that this idea of a plus b and a minus b, these are called conjugates. Right? So if you have a binomial and you just change the sign in the middle, those are called conjugates, right? Notice that they look the same except for the sign in between, right? So if you have a minus b, then you would write a plus b to be the conjugate, or if you had a plus b listed, then a minus b would be the conjugate, right? So those are conjugates of each other. So that's going to be helpful with rationalizing the denominator, right? So the very first one, I have 8 divided by 3 plus the square root of 5, right? So I wanted to get rid of the denominator, the radical in the denominator. So remember, we're going to use this idea of multiplying by the conjugate, right? So the conjugate of the denominator, which is 3 plus radical 5, is 3 minus radical 5. Just change the plus to minus, right? And then I have to multiply by the same thing in the top, right? So that way, this part is just equal to 1. Then I'm not changing the problem, right? I'm getting the same problem. So now when I multiply straight across, I would have 8 times 3 minus radical 5, and then in the denominator I'd have 3 plus radical 5 times 3 minus radical 5, right? So then this would be 8 times 3 minus radical 5 in the top still, and then the bottom, right, when you multiply that out, you end up getting 3 squared minus radical 5 quantity squared, right? Because that's the whole idea with the difference of squares, multiplying those, right? So then what this will give me is 8 times 3 minus radical 5. And notice I'm not multiplying the 8 through quite yet, because it's possible that I might might wait on that to see if this will reduce. So 3 squared is 9, and radical 5 squared is just 5, so we get minus 5. So then this gives me 8 times 3 minus radical 5 all over 4, right? So this will reduce, right? Because 8 divided by 4 is 2, so this becomes 2 times 3 minus radical 5. So now if I distribute the 2 through, I get 2 times 3, which is 6, and then minus 2 times radical 5. Right, so that's simplified, right? We remove that radical from the denominator. And then number 8, I have the square root of y minus 4 divided by 8 minus radical y, right? So again, the technique for this is to multiply by the conjugate. So this would be 8 plus radical y, right? Keep the same thing in the denominator, but change the sign in between, right? So this gives me radical y minus 4 times 8 plus radical y, all divided by 8 minus radical y times 8 plus radical y. right? So in the bottom, right, you can FOIL that, right? But that's just going to give me 8 squared minus radical y quantity squared, right? Because that's a difference of squares. And then in the top, we are going to have to FOIL this, right? So radical y times 8, right? That gives me 8 radical y. And then radical y times radical y, right? That gives me plus, in other words, it would be radical y quantity squared, right? Multiplying that twice. And that's, let me just make sure that this is a 4, right? So then if I take negative 4 times 8, that gives me minus 32. And then the last part I need to multiply is negative 4 times radical y, which gives me minus 4 radical y, right? And then these two guys are like terms, right? So 8 radical y minus 4 radical y is 4 radical y. And then radical y squared is plus y, and then minus 32 all over. And then 8 squared is 64. And then radical y squared is just y, right? So we get 64 minus y, right? And this actually won't reduce any further, so that's my simplified version, right? Remember, the whole goal here is I don't want a radical in the denominator, which I removed, right? So then the last one I have here, example 9, we have 5 radical 2 minus 2 radical 5 all over radical 2 minus radical 5. All right, so again, we want to multiply by the conjugate, so that would be radical 2 plus radical 5. Right, multiply the top and bottom by the conjugate, which this gives me 5 radical 2 minus 2 radical 5 times radical 2 plus radical 5 all over radical 2 minus radical 5 times radical 2 plus radical 5. So the denominator is just a squared, so radical 2 squared minus b squared, which would be radical 5 squared. Right, and then in the top we need to FOIL. So 5 radical 2 times radical 2 would be equal to 5 times radical 2 quantity squared. And then I would take 5 radical 2 times radical 5, so that would be plus 5 radical 2 times radical 5. And then I need to take these two and multiply, right? So that would give me minus 2 radical 5 times radical 2. And then lastly, multiply the last together, which gives me minus 2 radical 5 quantity squared. Right? So radical 2 quantity squared is just 2. So this would be 5 times 2 plus, and then these two things have the same index, right? So I could rewrite that as 5 radical 10, right? Because 2 times 5 is 10. So using that multiplication property of radicals. And then same thing here. This would be minus 2 radical 10, right? Because 5 times 2 is 10. And then radical 5 quantity squared is just 5. So this would be minus 2 times 5 all over, and this would be 2 minus 5, right? Because radical 2 squared and radical 5 squared, those squares cancel out the radicals, right? So then notice that, this cancels with this, right? Because that would be 10 and then minus 10. So then what we have left is, so these are like terms, right? So that would be, so 5 minus 2 is 3, so that would be 3 radical 10, all divided by, and then 2 minus 5 is negative 3. And then the 3's can cancel, so what we're left with is just negative radical 10, right? All right, so that's all I have for that section. Make sure you let me know if you have questions.